Sen varsın değil mi sadece? Şöyle yapalım. Güzel recording yapalım. Şey yaparsan, sorun varsa sor. Yapabilirsin yani, çekinme. Ha? 152 var, Gökhan veriyor. Orada Computation Culture diye bir şey var. Bilgisayara fokuslanıyor. Hangi iş nasıl yapılıyor gibi daha spesifik konularda. Today we are going to talk about Third Industrial Revolution, dates between 1950s and 2000s. So it is after Second World War to the recent .com revolution. So today's internet age and .com revolution starts with 2000. So today we are going to focus on that time between 1950s and 2000. When we go back to First and Second Industrial Revolutions, First Industrial Revolution, mechanical production and steam engine was the landmark. Then automobile and electricity determined the Second Industrial Revolution. The Third Industrial Revolution is related to electronics and automation. So automation and electronics was the key factor. Fourth Industrial Revolution is more digitization, artificial intelligence, and cyber physical systems, and biotechnology, etc. Determine the Fourth Industrial Revolution. When we focus on, this is a very nice graph. When we focus on gross domestic product of different countries, since the Jesus time, since year 1 and through the Middle Ages, we see that India and China were very significant in the old times in terms of world production. Then, because this is the ratio percent, then starting with 1900, the 20th century, United States increased significantly, and after 1980, probably here, China is expanding again, where Germany is declining to some degree, Japan is increasing, and others are also steadily at the steady level. United States is seeing some diminishing decline in the amount of countries' GDP over world GDP. Yeah. Alanlara ait. Yani şunun uzunluğu, şu uzunluk aslında. Şehir. Aslında bunların her biri bir pie chart. Pie grafikler vardır ya, her biri bir pie grafik, zaman içerisinde yürüyor. Bunu böyle şöyle katla, fon kartonu gibi. O zaman silindir grafik haline gelebilir. Zaman eksik. At some point, there was a more detailed graphics. At some point, related with cities, Ottoman Empire and Istanbul was also in the list in terms of world production. Third revolution, digital revolution, starting with 1950s. It brought semiconductors, mainframe computing, personal computing, and internet, taking us to digital revolution, and furthermore to fourth industrial revolution, which we will be discussing next week. With the third industrial revolution, things that used to be analog moved to digital technologies, like old television that we use, analog television to digital television, internet connected tablet and streaming movies. So that is also third industrial revolution. So digitization. That movement from analog to digital technology dramatically changed industries, especially telecommunications and internet. Internet is a telecommunication industry. So digital revolution enabled digital communication. Digital communication allowed internet. Electronics and information technology began to automate production and take supply chains globally. So information technology products are used to provide global production for all areas like animal production, farming, industrial production. Digital technology was used with the third industrial revolution. These are examples using digital technology. We can control fabrication of certain items in the industrial setting, industrial environment. One interesting thing is Thomas Edison was the first person that established a research laboratory aside from universities. So invention and innovation with the third industrial revolution became less the domain of the lone inventor. In the early days, when you are an inventor, people think that you are a crazy guy, Mujit, and you invent things at your home or at your castle, etc. You are rich, or a rich person is funding you, so you are an inventor. Then, with the Edison Menlo Park Research Laboratory, research become a business. Research becomes a business. So then organizations like Bell Laboratories, AT&T Bell Laboratories, where the transistor is found, invented, and miniaturized for electronics. So that's I have a picture of it. That's a very important step. Research as a business. This is Bell. This is the picture of the Bell Laboratories, the old building in New Jersey. By the year 2007, it is acquired by Nokia, and now it is Nokia Bell Laboratories. The book where we continue to follow today in this class, C programming language book, is written in that laboratory in 1970s. And they established the laboratory in 1925, and it was named as Bell Telephone Laboratories until 1984. So it's a huge time. Then all the transistor inventions, etc., communication inventions, digital communication were invented in those years. At 1984, Bell is divided into AT&T. Name is changed, AT&T Bell Laboratories, between 84 and 96. In 96, it is separated, Bell Labs, and by 2007, it is sold to Nokia, the same campus. This is a picture from 1970s. After the Second World War, research-based technological development was based not only on group projects, but also on science. So science is supported by the United States government. So scientific revolution, scientific innovations, not business innovations, scientific innovations enabled technological innovations, such as nanotechnology, etc. Because nanotechnology, for example, was studied by physics departments. So physics department works in, or chemistry department or physics department. They work in universities, they work in research labs, and they work in science. They don't think about products at the beginning. Therefore, they support science to enable steps for the technology. So that was the origin of research-based technological development, like silicon technology, transistor technology, vacuum technology, etc. Robotics. First, after the Second World War, research efforts increased, resulted in electronics, computers, jet engine, radar, rockets, nuclear power. After the nuclear bomb, they invented nuclear power stations. All of them demonstrate the help of science in technological change. So when we teach something scientific, when we teach, for example, derivatives, as I said in the previous lecture, momentum, inertia, Newton, or Maxwell equations, these are science, and scientific advancement helps technological advancement. So that was very significant in the post-war period. And since science is supported by government, it is supported by government because it doesn't create money immediately. Since it doesn't create money immediately, companies don't support it. Therefore, important role of the government supporting new, costly, and complex technology for the science is very important, and that happened in Western countries, starting with United States. I'm going to talk about that. These are the factors shaping technology at the end of the World War II. Those accelerated the rate of technological change and increased dependence on technology in the Western world. Before that, technology was only seen in production, And the life was not dependent on technology, but later, after the Second World War, life depended on technology, management of trains, etc., for example, or power generation, mainly by power of electricity and petroleum. This mid-century technology touched more and more people, and their dependence, that is capitalism, maybe, dependence on those technologies increased. Without cars, you couldn't travel to home. When I first went to United States for master's study, someone else dropped me in the campus. My house was 40 miles away from the campus. I couldn't get back to home from the campus because I didn't have car for that day. So I was dependent on transportation, private transportation technology for going between school and home. If that didn't happen, I probably would be studying in a city school where I can walk from home to school. But with the technology, people started to travel for work by cars. Therefore, dependency on that technology increased. At that time, after 1940s, 50s, 1940s, 1950s, United States built highways in the country so that people can travel, and the houses were built in suburban areas. Before that, rich people were living in closer districts in the city, but after 1950s, richer people started to move away from the center of the cities where public transportation is not available for bigger houses and bigger gardens. Electrical lighting and appliances, electrical power, automobiles, aircraft, consumer culture created the century of pervasive technology, intrusive and invisible technology. When did electronics, so we say electronics, when did electronics started? Term electronics, electron from electron. The transistor is developed in Bell Laboratories by Shockley experiments at 1947. Shockley, Bardeen, and Brattain. Nobody remembers those second and third names. People know Shockley. That was first designed for communication as an alternative to tubes that we have seen last week. But it was a very big step, the development of technology. The transistor, then electronic device, allowed for smaller, improved, and more reliable products such as handheld radios, portable radios, television, and sound reproduction systems, as well as computers. So this is so important. So computational devices are made in significantly smaller in size, lower in power, and therefore more powerful for the same amount of money. These are the guys who invented transistor: Shockley, Bardeen, and Brattain. They were awarded for the Nobel Prize in 1956 for their contribution in semiconductors, and the transistor you see at the bottom image is the transistor they worked for the first time in the museum. First transistor 1947. Then, after 1947, it is quickly expanded and produced in larger quantities. This is the very common way of production type transistor. When you zoom, you have a plate, you have junctions from each different sizes, and there is a bottom connector, and there are wires. At the top, there is a cover. That is this cover. This cover is at the top, and here is the plate. That was produced, that kind of transistor technology was still used, but produced in this way for over 40 years. Later, they started to use plastic cases and other materials. But still today, powerful transistors come in that packaging. This is the first transistor radio, Sony TR63, released in 1957. This is the first transistor radio, works with the battery. It is quite vintage and nice, right? And the original emblem of the Sony is actually really different. That is sold in mass markets to many people. And the brand Sony actually was not completely Japanese, since it was after the war company. If I am correct, it was heavily invested by United States investment. First transistors were germanium. First transistors were made with germanium material rather than silicon. But germanium was relatively expensive and relatively less stable, has certain problems, although it is usable. Silicon transistors are relatively cheap and have different characteristics. Invented in 1954 by Tannenbaum. That Tannenbaum is a different Tannenbaum from operating systems guy, maybe his grandfather. First commercial silicon transistor was produced by Texas Instruments in 1954. First silicon transistor, who was previously worked at Bell Labs. So laboratories like Bell Labs in Turkey, for example, Aselsan, those companies, those research centers are TÜBİTAK also. Those research centers are housed to other researchers at the beginning. So a person who developed himself or herself in Bell Labs later moved to Texas Instruments and continue their research in the other companies. So those core research labs also help other companies by providing people, by generating people in a school climate. After Texas Instruments invent transistors, areas in computation, analog computation, digital switching, communications, making computers and automation in factories and control systems increased significantly and in very fast fashion. These are, for example, power transistors. This is also power transistor. This is regular transistor. Each transistor has emitter, base, collector. So usually one of them is base, emitter, collector, or sometimes it depends on the type of the transistor. Sometimes the collector is on the left, sometimes collector is on the right. Who knows? You need to check the catalog for the transistor. But usually in these types, case is the collector. That's what I know. Case is the collector. This part. There are two pins on the other side. One of them is base, one of them is emitter, and collector is the external case. Then many transistors are placed on a silicon wafers, silicon place. We called them as integrated circuits, multiple transistors on one silicon. If we can pack multiple things on one silicon, that makes an integrated circuit. Also the resistors. There are resistors and transistors on the silicon piece. And these wires are gold, as we discussed in the previous break. It wasn't a new idea. It was the idea coming from vacuum tube time. In the vacuum tube time, German brand Loewe thought that instead of producing 3 tubes and selling 3 tubes for a radio receiver, let's produce them in one tube, but 3 different tube circuits. So 3 different tube circuits is produced in one tube. This is the diagram for it. So it is like 3 transistors in one package, 3 tubes in one tube. It was similar to modern integrated circuits, but it was invented in 1920s. The actual idea was the tax in radios were calculated by number of tubes inside. I remember it was the same in Turkey when we had TV receivers. Each TV receivers had passport registration for the government in our houses. It was because it was wireless device, or it was very important for war, etc. And inside it was saying lamba sayısı, number of tubes. So our TV was domestic TV produced by Grundig, and it had 5 tubes. So I knew that our TV had 5 tubes. And in Germany, there was a tax issue. Televisions and radios with lower number of radios at that time, lower number of tubes, paid less tax. So instead of producing radios with 3 tubes, Loewe generated 1 tube to reduce the tax taken for the radio receiver. Huh? Like a car, yes. So smaller engine. So it allowed radio receivers to have a single tube holder, which is very nice, and the radio became smaller actually. How to push research in a country? After the Second World War, in the United States, National Science Foundation is formed by whom? The guy was president was Eisenhower. The guy's name is forgot. Anyway, so in the original idea of National Science Foundation, to promote progress of science, to advance to national health, prosperity, and welfare, and to secure national defense. So defense, welfare, prosperity, and health is dependent on science. Therefore, we have to put money into science to improve our conditions. That is what they said in 1950 and started to give money as government to private research institutions and universities, just like TÜBİTAK in Turkey. So they supported science. Bir şey söyleyeceksin. Ha, tamam. That is the guy name is Vannevar Bush. Not George Bush. Vannevar Bush was the person who was responsible from Manhattan Project, the atomic bomb. After the Manhattan Project, he was also a professor. After the atomic bomb project, he was the science advisor for the American president. Then he said, we have to make a foundation to push more money into, more resources and money into research. And they formed National Science Foundation. It's American TÜBİTAK. Later, he was the head of MIT Electrical and Electronics Engineering Department, Vannevar Bush, or dean or something. NSF scope expanded over years to include many areas, including social and behavioral sciences, engineering, science, mathematics, education, etc. NSF is the only United States federal government agency with the mandate to support all non-medical field of research, except medical. Why? All non-medical. Because that happens in Turkey as well. When medical people and doctors, when medical doctors and engineers come together, medical doctors talk differently, and since their number is too many, for example, in a university with medical faculty, when you have 500 doctors in the medical faculty, all the rest of the departments may have 300 professors, but the medical faculty has 500 professors. Therefore, for the research decisions, progress, and projects, all dominated by medical faculty in those universities. For example, in our university, there is no medical faculty and engineering is improving. But if there is a medical faculty, all the money and resources are spent on medical facilities. I don't say research. Therefore, the progress is affected. Therefore, in the United States, this is different. And for the medical research, they have National Institute of Health, NIH. So the organization is different. They separated the organization. This is the Vannevar Bush, the guy, founder of the National Science Foundation, also the director of the Manhattan Project, then later MIT Dean, has a book on it, Endless Frontier. If you have time, get this book. and read it. It's a very important person. There is video of him on YouTube, short video of him on YouTube, talking about whether the atomic bomb was good or bad for the world. He says it was good because if they didn't do it, more people would have died in Second World War. So he said by killing 30,000 people at once, he prevented many more 100,000s from dying. Because he said it ended the war, nuclear technology. TÜBİTAK, in our case, is formed in 1963. Not bad. It is bad, but not bad. It has different subsections today. Marmara Araştırma Merkezi at Gebze, Bilgem at Gebze, SAGE Ankara, Uzay at Ankara, UME Gebze, TÜSİDE Gebze, Raylı Ulaşım Teknolojileri Enstitüsü RUTE Gebze, Marmara Araştırma Merkezi MAM Gebze, Bilgem, I repeat it. Yeah, it's a repeat. To make it longer. So basically, MAM and Bilgem is here. SAGE is in Ankara. YTE, there is YTE, Yazılım Teknolojileri Enstitüsü in Ankara as well. In Europe, there is a CERN as a counter, I wouldn't say countermeasure, but counter action to United States nuclear technology. As a counter action, CERN is formed. European Research Organization on Physics Particles Laboratory. It's a scientific research laboratory, but it will support technology later. It's in Genoa, between France and Swiss border, and has 23 member states, including Turkey. But Turkey, to prevent giving money, changed its membership status to observer rather than participator in recent years. We hope that it will come back, because as they do collaboration with the nuclear experiments, other collaboration and other types of research is also done together, and that will improve technological advancements such as World Wide Web. World Wide Web HTML language was actually first used in CERN. Technology origins, the origin of HTML goes back to CERN. NSF money in 2020, $500 million is distributed in TÜBİTAK. I'm sorry, TÜBİTAK, $500 million, so $500 million, right? 0.5 billion. In United States, $9 billion. $9 billion US dollars. CERN, 1.1 billion francs, Swiss francs. Fraunhofer in Germany, similar to TÜBİTAK of Turkey, 3 billion US dollars. And it's a German research organization with 72 institutes spread through Germany. each focusing on different fields of applied science. For applied science, not theoretical science, it's an applied science. Established in 1949 after the war. Again, for the theoretical research, Max Planck Society is there. Again, it's an independent, non-government and non-profit association of German research institutes. It's a society of, it's a collaboration between different research institutes, and all of them is called as Max Planck Society. In France, 3.5 billion USD each year. They established their organization in 1939, well before Germany and CERN. Institute of Chemistry, Ecology, Physics, Nuclear, etc., etc., etc., Computer Sciences, National Science Research Center of France. In UK, it is different. UK doesn't support research by government. They have, it says the UK government funds research in universities through dual support mechanism. Dual support mechanism, annual grant from the funding councils to support the research infrastructure, and specific project grants from the research council to fund particular piece of research. So there is an ongoing regular money and there is an extra money. It is like university getting TÜBİTAK projects. Our salaries are paid by government, but if we get additional projects, we get additional money for the resources. But there is no single foundation in United Kingdom to support research. It is different. It has a council, Science Research Council, Science and Engineering Research Council, Engineering Physical Science Research Council. Name is changed, but in terms of budget, it doesn't distribute money as other countries does. It is just an organization. Further developments happened in Third Industrial Revolution during that time, between 1950 and 2000. In United States, Germany, Japan, United Kingdom, France, and China, plus Russia. After the Soviet Revolution, Russia also made scientific and technological research and supported research. That's basically it for today. Next week, we will be discussing the things that are related to Fourth Industrial Revolution today, and we will focus on today's developments later in the in coming weeks. So we have 4 more weeks. Basically, we will discuss about Fourth Industrial Revolution, today's big data change, digital revolution, and then we might have additional resources to read for the remaining time. Okay, that's good for today, I think. Any questions?